Section 4.8 will focus on the integration of inverse trig functions. We'll take a look at a couple examples. We won't need to do too many, and then you can try a couple on your own. And of course, we'll go over any questions that you have in class. First thing we need to do is remember from way back, basically where the derivatives came from, because we'll need to use those in order to integrate. So there you can see here the derivative of arcsine and arctangent. And so what we're going to be looking for in our integral is this format, right, to appear in the integrand. So it'll take a little bit of getting used to, but keep these handy as we go through some of the examples. So the first thing I think you'll want to key in on is the difference between recognizing if this has arctangent or arcsine potential. And so it's actually a very easy distinction. It really comes down to whether there's a square root involved or not. So when you see the square root, then you are definitely looking at a potential arcsine problem, whereas when you see the sum of squares, which is what you see in example 2, you're looking at a potential arctangent problem. So given what we saw on the previous page in the formulas, we start off example 1, and now we've already determined, because of the square root, that we're dealing with an arcsine problem. The question is, how do I then go about integrating it? And so we know that the integral of something like this is going to turn into arcsine of u over a plus c. Question becomes, what do I pick? And so a will always be the number that's being squared. And so in this case, it's 2. Right, it's going to come from there. U will always be the function that's being squared. So in this case, it's x. And of course, like always, we want to create a du, and then that would be dx here, so that everything matches. So we're still playing the same matching game that we've been playing over the past couple lessons. So we're trying to retrofit this into the integral expression we saw. So we see that the dx is being replaced by the du, so I can kind of put that over here. And I can even say that this takes the form square root of a squared minus u squared. So as soon as I see that, that form is good to go, then I'm ready to transition right to my final answer. So in this case, it would be as simple as saying arcsine of x over 2, right, u over a, and then plus c. Now, in example 2, we can see there's no square root, so that would tip us off that we're potentially looking at arctangent. And because of that, we have to kind of remember that formula is just a tad bit different. So there's a 1 over a on the outside. And then on the inside, it looks very similar to arcsine. So very, very much like when we did arcsine, we're looking for that constant. So in this case, it would be the square root of 2, because when we square the square root of 2, we get 2. And u would be 3x, because 3x squared is 9x squared. Here it's very interesting to note that the du, though, is 3 dx, which means you're off by 3. So as we've seen in the past, that would require you to put a 1/3 on the outside here as you begin to set up your integral. And so now it looks like it takes on this form, 1 over a squared plus u squared du. And so if that's the case, then we have a final answer of 1/3 and then we have times 1 over a, so in this case it was 1 over radical 2. And then we have arctangent u over a, so 3x over radical 2, and then plus c. And we could pretty much leave it like that. All right, and finally, we have these 3 examples here where I want you to try them. As usual, pause the video, come on back. What I am going to do, though, is I'm going to keep I guess I'm going to keep some things from the answer, in the sense that I will come back and I'll tell you what I'm picking for A and for U, but then I'm going to just write the answer. So that way you can kind of like continue to investigate if you're not getting what I'm getting, and of course maybe that will spur on some more questions when we meet in class. So take a couple minutes here, try 3, 4, and 5, and pause the video, and then come on back and we'll get you the answers. All right, so for example 3, I was using A equals 2, U equals 5x, which then meant du equals 5 dx. When all is said and done here, final answer in example 3 was 1 over 10 tangent 5x over 2 plus c. For example 4, we were using a equals 4. U was actually equal to radical 3 and then the x is outside the radical, which yields du as radical 3 dx, so we're off by that radical 3. So the final answer here was 1 over radical 3 arcsine of radical 3x and then over 4 plus c. And finally, in example 5, a is equal to 3 here. U is equal to e to the 2x, because when you square e to the 2x, you actually get e to the 4x. It works out nicely here. But du is equal to 2e to the 2x. So we have a lot of stuff going on. Final answer here wound up being 17 over 6 arctangent of e to the 2x over 3.